Greetings, JoAnne Myers here. Quick intro and explanation of complex numbers. Complex numbers are also called the imaginary numbers. They arise from the situation of having a -1 under a radical. Taking the square root of a negative number does not exist in the real world. Negative times negative is positive. Positive times positive is positive. So there's no way to square something and get a negative number. Therefore, we cannot take the square root of -1. When we have a situation like this, where there is no such thing, they basically chose to call it imaginary. The imaginary number is written in the form a plus bi, where I is the imaginary part. If I is defined to be the square root of -1, which again does not exist in the real world, but we have it in equation form. The rules in math, if you're given an equation, not an expression, but an equation that has two sides of the equal sign, you can do pretty much whatever you want to both sides. Square both sides, we now have I squared is the same thing as -1. So when we're working with complex numbers and imaginary numbers, we use the fact that I squared is the same thing as -1 because we were given the fact I is the same thing as the square root of -1. In math, when two things are equivalent, you can choose to use whichever is most helpful to you. It is more often more helpful to use I squared equals -1. All right, we're going to express these equations. We have these expressions that we're going to express as a complex number, meaning we don't want to have or use a negative under the radical. Five plus the square root of -49. The square root of -49 is not a real number. We're going to rewrite this, given our new info. Quick reminder over here, these are our rules that those who have gone before us have proven. The square root of a times b, where we're multiplying under the radical, is the same thing as the square root of a times the square root of b. Division, same thing. Those who have gone before us have proven order of operations. This square root of a divided by b will always yield the same numerical value as take the square root of a, take the square root of b, then divide. Given that fact from previous lessons, we can rewrite this as 5 plus the square root of -1 times the square root of 49. So we have 5 plus I times 7. We put the number before the real part, before the imaginary part, and this is our simplified version of what we are originally given. Again, this is an expression. We are rearranging the expression. We are not given an equation, so it's important to remember we're not allowed to do the same thing to both sides of the equation because we don't have both sides. We're only given half the story, so to speak. Equations are what we can do the same thing to both sides. Expressions are not. Number 2, given this expression here in the purple box, I want to express this in a more simplified way. Well, we're not allowed to leave negatives under the radical. So this becomes 4 minus I times the square root of 36. Another way to approach these problems, the -4, again, as I did previously, I could rewrite this as -1 times square root of -1 times the square root of 4. Personally, I'd rather skip this step and just write it as 2i. Let me explain quickly where it's coming from. The I is the -1, square root of 2 is 4. But we would rewrite it as a plus bi or 3 plus 2i. My first part here, working with this part next. 4 minus I times 6, 4 minus 6i. Now again, we need to distribute. Distributing the negative sign. I'm looking at it 4 minus 6i minus 3 minus 2i is the same thing as 4 minus 3 minus 6i minus 2i. Once you've gotten rid of any negatives under the radical, converted it to I, you can, for the most part, treat I just as you would treat it any variable expression, any variable. The difference, and what you need to remember, here's a little thought bubble again, is that whenever you have an I squared, it is the same value as -1 in the real world. So here, when we're multiplying these complex numbers, multiply my first numbers. 3 times 4 is 12. 3 times a positive 6i is 18i. 3 times 6 times I. -2 times I times 4 is -8i. My last term, -2i times positive 6i. Negative times positive is negative. 6 times 2 is 12. I times I is I squared. Now I simplify, combine like terms. I have 12 plus 18 minus 8 would give me plus 10. Now this becomes minus 12 times a -1, because again, given an I squared, we know that I squared has the same value as a -1. This becomes 12 plus 10i. -12 times our -1 would give us a positive 12. Again, continual, always simplification of your problem. 12 plus 12 is 24. Again, we always write complex numbers in the form a plus bi, where a and b are elements of the real number system. Final answer. Add, subtract, multiply, and divide complex numbers similarly as if the I were a variable. Remember that the I squared always converts to -1. When asked to graph, if we're going to graph three plus 2i, our x number line is still the real number system. Our, what was normally the y coordinate or y number line, this is going to be our bi portion of the number system. Our x number line is our a. Our y number line is our bi. So if I'm to graph 3 plus 2i, I would go over 3 and up 2, and that would be the point 3 plus 2i on the number system. If you have questions, please keep them coming. Keep up your good work.